Okay, this is going to be the advanced math review for 2019 for my class. All right, this first question, what you're going to want to do is you're going to go to inverse cosine and put in 0.6541. Okay, that gives you your first angle being 49 degrees. Okay, so that means that the reference, if it's here, that means the reference angle will also be 49. Now, what you're looking for is where cosine's positive. And you might want to write this down. If you're in quad 1, all is positive. If you're in quad 2, sine and cosecant are positive. If you're in quad 3, tangent and cotangent are positive. If you're in quad 4, cosine and secant are positive. All right? So you're going to keep that in mind. We're going to reference that chart, okay, as we go. So the other place that cosine is going to be positive will be in quad 4. All right, so in quad 4, if I apply 49, that's going to work to 360. So 360 minus 49 is 311. Okay, find the values. Okay, now this should have been negative 4.5675, so make that adjustment. So what I would do is I can't do secant, but I can do cosine, and I can flip that so it's 1 over negative 4.567. All right? So the first one that works is 102. Now I'm looking where secant or cosecant is going to be negative. All right? It's going to be negative here and here. All right? So 102 would be in this quadrant, and I would apply the reference angle of 180. So 180 minus 102 is 78. Okay, so 78 is the reference angle, and so now I'd apply 78 down in that quadrant. So that's going to be 180 plus 78. Which will be 258. So the two things that worked there were those two. Okay, moving on here. Inverse sine of negative square root of 3 over 2. That's negative 60. I want to add 360, so that would be 300 degrees. Okay, 300 degrees would be down here. I would compare to 360. So the reference angle is 60. All right, where is sine negative? The other part sine would be negative, would be down in that quadrant. So that would be 180 plus 60. So that one works as 240. Okay? Make sure you can see my calculator that I'm not off the screen. Nope, I'm good. Okay, good. All right. Find the degree measure. What I want to do there is take 3/4 and multiply by 180. That will give me my degree measure. So that's going to be 135 degrees. That would be right here. All right, for my reference angle, I would be comparing to 180. So my reference angle is 45. All right, find these trig functions. Okay, all right, well, we had this special right triangle of 45 or pi over 4, 2, square root of 2, square root of 2, hypotenuse, opposite, adjacent. So if I fill those in, that would be square root of 2 over 2. All right, square root of 2 over 2. Tangent would be square root of 2 over 2, which would be 1. Cosecant is the flip of this, so that's 2 over square root of 2, which is just square root of 2. And that's the same thing here. 2 over square root of 2 is square root of 2. Now, at 3 pi over 4, that would be in this quadrant, quadrant 2. The only things that are going to be positive are sine and cosecant. So all of these other ones, and then I think, whoops, the cotangent is also that. Okay? I think that's it for that page. Going to number 6. All right, 330. So what I want to do is figure out what the reference angle is. 30 degrees. All right, 30 degrees is the reference angle, so that triangle would be 1 square root of 3 and 2. All All right, and it's down in that quadrant. So for sine, it's 1/2. Cosecant, it's 2 over 1. For cosine, it's square root of 3 over 2. For secant, it's 2 over square root of 3, which becomes 2 square root of 3 over 3. For tangent, it's 1 over square root of 3, which becomes square root of 3 over 3. Cotangent is square root of 3 over 1, which is just square root of 3. Okay? In this quadrant, only cosine and secant will be positive. So these are going to be negative. Okay? All right, last bit with the unit circle. So rapid fire ones. Okay, 240 would be down in here. So I would be comparing to 180, so that's going to be a 60-degree reference angle. So that's square root of 3 over 2. Here, the only things that are going to be positive are tangent, so that would be negative. All right, 180, I look at this point of negative 2, 0, x and y. Tangent is really y over x, so that's 0 over negative 2, which would just be 0. 7 pi over 6 is the same as pi over 6, which is the same as 30 degrees. Okay, so what that would look like is 1 square root of 3 and 2. Okay, cosine would be square root of 3 over 2. All right, this is also in this quadrant down here, so that would also be negative. Okay, negative 3/4 pi. What I would have to do is add 2 to that, get a common denominator, so that's negative 3/4 plus 8/4, which is 5/4 pi. Okay, all right, that would create this triangle. All right, the 45-degree one. So that's square root of 2, square root of 2, 2. So they want me to do cosecant. That would be 2 over the square root of 2, which would just be square root of 2. All right, 5/4, I'm down in this quadrant, so that would also be negative. Okay, negative 30 degrees would really be the 331. All right, so we just did that up here. All right, I'll save us some time. Tangent of 330 is negative square root of 3 over 2. I'm sorry, negative square root of 3 over 3. 7/3 pi, you'd have to subtract 2 over 1. So that's 7/3 minus 6/3, which is 1/3 pi. All right, so what that's going to look like, that will be the 60-degree triangle. All right, which is square root of 3, 2, and 1. I'm sorry, square root of 3, 1, and 2. Cotangent would be 1 over the square root of 3, which would be square root of 3 over 3, and it's in quad 1, so it would be positive. Okay? Moving on to 8. The idea here is this is x, this is y. So a and x, o and y. I can do Pythagorean Theorem for that. Always do Pythagorean Theorem as positive. 2 squared plus 4 squared. Okay, would be 20. Take the square root of 20. That's 2 square root of 5. All right, so I got sine, cosecant. So sine would be 4 over 2 square root of 5. This would be 2 square root of 5 over 4, which would reduce to 1/2. Okay, I'll show you the other one, how that one reduces. Cosine would be 2 over 2 square root of 5. Secant would be 2 square root of 5 over 2, which would just be square root of 5. Tangent, 4 over 2, which is 2. And cotangent would be 2 over 4, which is 1/2. All right? Now, for these two, what I would do is just use the fraction button in your calculator. 2 square root of 5 over 5. And this one, all the fractions you can type into the calculator. 5 square root of 5 over 5. Okay, moving on. All right, similar concept. Quad 3. So what I use is this is A and this is H. All right, meaning this missing one will be 12. You can use Pythagorean Theorem or the triples. Okay, all right, now since you're in quad 3, okay, all right, that means the only thing that will be positive are tan and cotangent. So sine is 12, 13, cosecant 13 over 12. All right, cosine 5 over 13, mean secant was 13 over 5. Tangent is 12 over 5. Cotangent, 5 over 12. Okay? Alright? Should be all good at those trig functions. Okay? Alright, so one thing is tangent will be positive, so these will be negative. Okay, moving on to 10. Okay, this is about drawing A and B triangles and looking at the quadrants. The triples are vital here for this. So this is O and H. So that's O, H, A. That's 3, 5. Missing side is 4. And this is quad 1. Okay? This is the B triangle. That's A and H. As you notice, I will put these as positive numbers. This will be 24. All right, this is quad 3. I'm going to keep everything positive and then do the negative parts. Okay? So if I apply the formula here for this, all right. So if I look at sine A minus B, that's going to be sine A cosine B minus cosine A sine B. Now all I got to do is put in the fractions. Okay? Alright? So for sine A, okay, I'm going to look at the A triangle. Alright? So the A triangle, that is going to be, sine would be 3 over 5. And since that is in quadrant number 1, it's going to be positive. Okay, times cosine of the B triangle. That will be 7 over 25. Now, since the B triangle is in quadrant 3, the only thing positive are tangents. So I'd make that minus. Okay, minus cosine would be 4 of the A triangle, would be 4 over 5. 4 over 5 there. Times sine of the B triangle. Sine of the B triangle would be 24 over 25. Since it's in quad 3, it would be negative. That's all you got to do for that. So what I'm looking at is on that is what's positive, what's negative. 3/5. Okay? Same thing here. That would be 24 over 25, and that would be 7. Okay, it's a quad 1 triangle again. That's A over H, 3 over 5. Okay, missing one would be 4. Okay. All right, now I want to do cosine A plus B, which is cosine A plus cosine B. I'm sorry, cosine A times cosine B minus sine A sine B. Okay, cosine A triangle are going to be positive. These other ones will be negative because they're quad 3s. Okay, so cosine of the A triangle, okay, would be 7 over 25 times cosine of the B triangle, which would be negative 3 over 5, minus sine A of the triangle, 24 over 25, which would, the A triangle is going to be positive there, times the sine, which is negative 4 over 5. Which, once again, is 3/5. It's not always going to perfectly work out like that. All right? All right, let's move on to 12. O and A. This has to be 13, which is the hypotenuse. All right, the sine 2b would be 2 sine of A, cosine A. This is a quad 2 triangle. All right? So the sine will be positive, cosine will be negative. And that's because it's right here. Negative 120 over 169. All right. This is just some simple trig stuff. A, B, C. B is 90. Okay, A is 40. Little c, which would be right here, would be 20. The easiest thing to find first is this angle. These angles have to add up to 180, so that's got to be 50. To get little a would be right here. All right, this is hypotenuse, opposite, and adjacent. So the two things I have here are opposite and adjacent, which would be tan. So tan of 40 equals a over 20. When you get these, what you do is move that 20 up in front. That's 16.78. I'm going to scribble this out. I'm now going to find b. Okay, so now I got hypotenuse and adjacent, which would be cosine. Okay, now when you have this one, what you do is you take this whole thing and put it underneath. You switch spots. So what that would look like as a fraction would be 20 with the cosine of 40 being underneath. That's 26.1. Okay, moving on to 14. Okay, whoa, oops. All right, so I got, this is B, this is A, this is C. All right, little b is 13, little c is 5. So the easiest thing to find first is little a, okay? All right, I can do Pythagorean Theorem or know the triples, and I know that that's 12. I'm going to get this angle first, so angle A, so this is hypotenuse, opposite, adjacent. So the two things I have is adjacent and hypotenuse, so cosine of A is 5 over 13, and I would do the inverse. That's going to be 67 degrees, okay, for A. And then all I got to do to get the C is just do subtraction. 180 minus 67, or minus 90 minus 67. That's 23. All right. It's a blank page. 15. Angle of elevation. Angle of elevation will be right here. Measures the distance to the tree. This would be the distance, 24. What is the height? Simple hypotenuse, opposite, adjacent. I got hypotenuse and adjacent, so that would be tan. And I would move that up in front to get that answer. 16.80. Okay? 3 proofs, 3 graphs, and we're done. Okay? Well, what we want to do is write these proofs in the relationship of x, y, and r. Okay? So this would be 1 plus y squared over x squared equals r squared over x squared. I would need to get a common denominator by multiplying both of these by x squared. So I get x squared plus y squared all over x squared. Okay? This would be replaced by the given. So that's what my answer would be. Okay? For this one, I'm going to want to handle this first. So that's going to be y squared over r squared plus x squared over r squared divided by r squared over x squared equals 1 minus y squared over r squared. I want to handle this first though. Always handle the parts within the fractions. Well, this already has a common denominator, so I can push this together. The givens will tell me that that is r squared over r squared, okay, which would just be 1. Now what division does is it flips this second fraction. So that's going to be x squared over r squared. So I want to handle all that on this side. On this one, I would just multiply this by r squared on both sides. So I got r squared minus y squared all over r squared, which this will be replaced by the given, would just be x squared over r squared. Okay? Once again, on this side, I want to handle this first. So that's going to be r squared over y squared minus 1 divided by r squared over y squared equals x squared over r squared. Okay? So once again, I want to do this first, so I would need a common denominator. Multiplied by y squared, multiplied by y squared. So that would be r squared minus y squared all over y squared, that would turn into, with the givens, x squared divided by y squared. The division, what that does is flips that, so it's y squared over r squared, and then I'm allowed to cross these out. So it's x squared over r squared equals x squared over r squared. Okay? That's it on that page. Okay, some graphs, and we're done. All right, amplitude here would just be 1. The period would be 2 pi divided by 4, which would be pi over 2. Phase shift would be none. Vertical shift would be -3. Okay? Now, what I want to do, these would be my starting angles for this. Sine would be 0, 1, 0, -1, 0. So I say, Mr. Evans, how do we get those values? Well, you can always just type them into the calculator. Sine of 0 is this. Pi over 2 is 90. That's how I get this. 180. -1. So I know how those convert. Okay? Now, what's going to happen to our angles here? Our angles are going to be divided by 4, okay? And our values are going to be times -1 minus 3, okay? All right, so for the angles, all right, I'm going to write those down here. 0 divided by 4 would be 0. Pi over 2, well, you can either type pi over 2 or type a half, doesn't matter. Pi over 8. Pi divided by 4 would just be pi over 4. 3 pi over 2. It's always the one that's most confusing. 3/8 pi. And 2 pi divided by 4 we discussed already is pi over 2. Okay? So I got to go from that side. All right, now I want to do the values, which would be times -1 minus 3, which is -3. 1 times -1 minus 3 is -4. That's going to be -3 again because it was 0. That's going to be -3 over here. All I have to do is figure that one out. -2. Okay? So, leave yourself some space. Okay? So if you want to do 0, I would use these as, you could use this as, if you want, you can use this as pi over 8, or 1/8. Well, let's start with this. Alright, let's pretend this is pi over 2. Let's pretend this is pi. Okay? So if you cut pi over 2 in half, that'd be pi over 4. This would be 3 pi over 4. Alright? Well, I'm sorry, that's not right. Hold on. Well, these aren't the best graphs to use. Okay, so I got 0. Alright, let's just go pi over 2. Make this easy on ourselves. Pi. Okay, 3 pi over 2. Alright, 2 pi. Alright, to make this easier on ourselves, these will be fourths. That's 1/4, 3/4, 5/4, and 7/4. And then if you want to cut these could be the 8ths. Okay, so it'd be 1/8. Alright, so at 0, I'd plot -3, 1, 2, and 3. At 1/8, I would plot -4, with 1/8 being here. At 1/4, I'd plot -3. At 3/8, I'd plot -2. And at pi, I would plot this. So this is what I would look like. So I would just use these lines as the fourths and then cut those little boxes to make 8ths. It's probably the easiest way to do the graph. Okay? The amplitude here would be 1. Period would be 2 pi divided by 1, which would be 2 pi. Phase shift would be -pi. Okay? Vertical shift would be 0. Okay? All right? Now, we erase this real quick. All right? So the angles are very similar that I would start with. I would start with 0, pi over 2, pi, 3 pi over 2, 2 pi. All right? Now the values are a little bit different. It would be 1. Cosine of 90 is 0. Negative 1. Zero, and then that would be 1 again. Okay? Lower this just a little bit. Negative 1, 0, 1. All right. Now, what's going to happen to our angles here? Our angles, the only thing that's going to happen is they're going to be subtracted. Our angles are going to be subtracted by pi. Our values, actually nothing is going to happen to the values because I don't have anything out here. There's no vertical shift. So all I got to do is subtract pi. So 0 minus pi, obviously, is negative pi. All right, half. Negative pi over 2. Pi minus pi would be 0. 3 pi over 2 minus pi is a half pi, or pi over 2, and this would just be 1 pi. Okay? So I'm going from negative pi over 2. Okay? So pi over 2, pi, 3 pi over 2, 2 pi. If I have to go the other way, this is a negative pi over 2. All right, skip 1, negative pi. All right? So, at negative pi, I would graph 1. At negative pi over 2, I graph 0. At 0, I graph negative 1. At pi over 2, I graph 0. And at pi, I graph 1. So this is what my graph would look like. Okay? Moving on to the last problem. Okay? This is tangent. Amplitude would be 1. Oops. Amplitude would be 1. Period would be pi divided by 1, which just says pi. Phase shift would be pi over 2. Vertical shift would be 0. Now for tangent, it would start out as 0, pi over 4, pi over 2, 3 pi over 4, and pi. Okay? So they work in quarter increments. Okay? So I said, Mr. Evans, how do we figure those out? Okay? Use calculator. Tan of 0, 0. All right, pi over 4 is 45. 1. That means undefined. All right, well, 90 and 45 would be 135. Okay? Now, the only thing that's going to happen to our angles, all right, is going to be added by pi over 2. So that would be pi over 2 for this one now. Pi over 4. Plus pi over 2. Would be 3/4 pi. Pi over 2 plus pi over 2 would be 1 pi. 3 pi over 4. Pi over 4. Pi over 2. Okay? So what I would do here, 0, pi over 2, pi, 3 pi over 2, 2 pi. So very simply, these would be the fourths. So 1/4, 3/4, 5/4, 7/4. If you needed the eighths, cut those. Okay? All right, so at pi over 2, I'm at 0. At 3/4 pi, I'm at 1. At pi, I'm going to be undefined, so I do this little dashed line. 5/4, I'm at -1. And this I'm at 0. Now, what you have to do with tangent, just go ahead and draw the curve through those points. Okay? It makes this shape. All right, you don't have to be overly accurate. Okay, but that's how you do it. Okay? If you prepare with this video, you should do well on the final.